Yeah, you need to get your computer out. A new one? Why? Okay. Quotient means that we're dividing something. Okay, quotient means we're dividing. Quotient means we're dividing today. Friday we did product. So product was what on Friday? Multiplication. Today we're going to be doing division. All right. For quotient of powers, let's open this up. We're going to show an example on the inside here. We're going to have x to the third power over x to the seventh power. And I'm going to write out what that equals. So I'm on the inside flap. How many x's are going to be on top that we're multiplying? 3. What part do we call that 3 in that power? Is that the base, the exponent? The exponent is 3, and the base is x. Yeah, I asked what the 3 was. X times x times x. That's okay. Your brain was at least thinking about math, and I appreciate that. All right, on the bottom, how many x's? 7. 3, 4, 5, 6, 7. Zach, focus. MK, put your anime away for a little bit. Thank you.
Anime?
Manga, sorry, not anime. All right. Hey.
Which one?
Andrew, refocus. All right, now we just talked about on the board when we have a number divided by itself, like we had 5 divided by 5. What is x divided by x? One person said it. Any number divided by itself is 1. Like 5 divided by 5 is 1. 3 divided by 3 is 10 divided by 10. X divided by x, 1. Okay, so I have an x. I have another x over x here. X divided by x, that would equal 1. And another x divided by x, 1. Now there's no more x's in the numerator that I can make into 1s, so I have my leftovers. How many x's do I have left over? 4. But those 4 x's, are they in the numerator, the top, or the denominator, the bottom? Good, the bottom. Good. X to the 4th, the denominator. So there's 4 x's. They're in the bottom. And all those x's on top that some teachers would say canceled out, they really divided to equal what? 1. So 1 is left in the numerator. Similar to like if there's nothing left in the denominator, if we just had like 5, it'd be 5 over 1. Okay, same thing if I have x's on the bottom, if I have nothing on the top, we can always put a 1 on the top. Okay? So, how could I have gone from this problem to this answer without writing all of this work? Yeah, we did subtracting. 7 minus 3. So, to divide powers with the same base, we subtract the exponents. To divide powers with the same base, we subtract the exponents. Hey, Zach. Guys. Hi. Okay. Maybe you just don't talk to her anymore. Hey, Fatuma. You can do this. Refocus. All right. So if I have a to the x over a to the y, and I want to write that just with one a, it'd be a to the x minus y. We're going to subtract, so make sure we have a minus there. Now, most of you probably won't read this in words. You'll look at an example and you'll be like, oh, I get it. We subtracted. Because a lot of us look at it that way. Some of us are word-based. We like reading it. So if you are, that's where you're going to read that. Let's work through this. Bro, what do you have to say right now? Does that have to do with this problem? Okay, what do you got about this problem? What do you see?
I see numbers.
Good, we see numbers and we see letters. Which bases are the same bases here? M's. So we're going to look at these M's together. And we're going to look at P's together. So those are the ones with the same base, the M's and then the P's. So really important that we start by matching up those M's and those P's. John, put away your phone, dude. Oh, you're sleeping? What are you doing? You're sleeping. Stop sleeping.
Wake up.
You didn't have your phone out, sorry. The way, it was like an optical illusion for a second. I thought your whole back was facing me, but it was just like the way that the shadows were playing. That was very confusing. My brain just got blown. All right. M to the fifth over m to the third power. What are we going to subtract? 5 minus 3. And what is 5 minus 3? 2. Now, I have to think where are those leftover m's going to go? On the top, because there's more m's to start with. So m squared goes on the top. Okay. Lou, Andrew, I'm going to take away your music. Holy cow. This is too much. The jam sessions you guys are having. Alright, now for my p's. How many p's, what will I subtract? Good, 11 minus 6 is 5. But I need to think, where are those extra 5 p's? Just focus. Okay, why are they in the denominator?
Because the 11 was on the bottom.
Good, the bigger number of the two is on the bottom, so our leftovers end up being on the bottom. So p to the fifth power on the bottom. Holy moly, we got a lot of conversations going on today. Good thing we only have one thing left, yeah. So, when it's dividing, hey, period 3, holy cow. Whoa, side conversation central here. Blake, stop talking. Alright, so when we're dividing, we see that line dividing. But to divide, it actually means we're going to subtract the exponents. Because when we divide, it makes ones, like this, where we have x over x, x over x, x over x, and then we have leftovers. And so we could write it out as m times m times m times m. We could do 5m's over 3m's. And then cross out the 3 that make ones, and we'd be left over with 2. And the 2m's left over would be left over on the top. Okay, Smudger, that's a lot. Alright, so here we go with the next one. We're going to do power of a quotient. So power of a quotient means we have a power on the outside, and we have a quotient, a dividing, on the inside. Okay, so I'm going to open that up. I'm going to close this one. Alright, so power of a quotient. We're going to show that out in the inside. We're going to do that longer way to do it here to show why it works. So I have the quantity of a squared over b taken to the third power. Alright, so for a squared over b to the third power, what are we actually taking to the third power?
Everything.
Everything, all that's inside. So it's really a squared over b times a squared over b times a squared over b. Holy cow. Alright, now for those of you that are, some of you can visualize that a squared, a squared, a squared. Some of us are still wanting to write that out, and that's okay. That's a nice part about exponent properties. All these problems, you could write everything out. You could do all the steps. What does a squared mean? Not 2 times a. A times a. There's 2 a's. So a times a. Times, what's a squared? A times a times a times a. When we multiply fractions, we just multiply all the numerators. And then we multiply all the denominators. How many b's do we have on the bottom? 3. All right, so how many a's do we end up on the top with? 6. And how many b's on the bottom? 3. So we end up with a to the 6, b to the 3rd power. How could I have skipped all that work? If you want to do all that work, if that's what makes sense to you, do that. That's not wrong. It's okay to do that. These properties, though, allow us to skip over doing that hard work and be able to use kind of these rules to help us go through it faster. So how could I have gone from this problem to this problem? Good. We multiply that 3 with the 2 and with the bottom exponent. Perfect. So for our rule here, it says multiply the exponents in the numerator. Numerator, which numerator is just the academic word for what? The top. And the denominator. Hey, not appropriate. And denominator, again, is our academic word for the bottom of a fraction. And we multiply it by the outside exponent. Alright, I made a mistake on this bottom part here, so we do need to fix that quick mistake before we actually write out this part. This on the bottom is supposed to be y to the b, not x again, so make that a y. Because otherwise it would simplify too much. We don't want to do that. Alright, so when we have that outside k, we're going to take that and multiply it by the exponents. So we have x to the a times k. And then on the bottom, we switch that to a y. So make sure you got that switched to a y, because otherwise you'll be like, what? Where'd that come from? And on the bottom, we have y to the b times k. So we take that k, and we're giving it to both the numerator and the denominator, both the top and the bottom of the fractions. All right, we have one example left here. And then you have the rest of the time for your quick checks, which will be good because some of you didn't do the D1 quick check. Alright, so here we have 3y squared over 5x to the 3rd w, all taken to the 5th power. Alright, so all I see is the 2 and the 3. Does that mean I just do 5 times 2, 5 times 3, and I'm done? No, what parts do I still need to have? The bases. Which base? What does this 2 go with? The y or the 3y? Just the y. So what's the exponent of 3? 1. So I need to throw in a 1 there. Blake, Ruby. All right, what about the 5? 1. What about x? 3. And w has 1. So I need to take that outside exponent, that 5, and I'm going to multiply it by like all of those inside ones. Some people like to draw on those arrows. To me, it's a little overwhelming, so I do it really lightly. But I'm going to take that 5 and multiply it by all those inside parts. Okay, so 1 times 5 is 5, so 3 to the 5th power. Y to the 5 times 2, 10. 5 to the 5 times 1, 5. X to the 3 times 5, 15. And W to the 5 times 1, 5. So anytime we see those parentheses do tell us to multiply. Now our last step here is to simplify. Do I see any bases that are the same? 5 and 3 are the same number? No, but they are numbers, so we can actually find their answers. So we have 3 to the 5th power. Now eventually I will have to check it as a fraction, so I'm just going to put it as a fraction right away. So 3 to the 5th power over 5 to the 5th power. And that way my calculator will simplify it as we go. This time it didn't need any simplifying, but sometimes it does. So we get 243 on top. 243 y to the 10th power. And then on the bottom we have that 3,125. X to the 15th power. W to the 5th power. All right, you did all of this work. So since you did all this work, what should you do with all of this work that you already did? Glue it in right now. Otherwise, if I find them at the end of the day, I do throw these ones away. So glue those in. Front table, I got you with glue in just a second. Oh, you found glue? Yeah. Perfect. All right, so get those glued in. Those are the notes for today. Tomorrow we have another notes, and then Wednesday we will pause to do some practice and combine a lot of this information, which will be great.
Can you go back to it?